All right, so Alexa already introduced Paperspace to you. I am going to give you a step-by-step walkthrough of how to get the 2D to 2D style transfer experiment up and running on Paperspace. I will break this into steps so that people are on the same page when we are trying to execute the experiment. I hope everyone is trying to run the experiment in parallel with me so that you get an idea of how to set up on Paperspace and get results. Otherwise, of course, the repository has tutorials that you can refer to in case you uh, are not running it right now and you want to check out how to upload data or run the experiment. So onto Paperspace. In case you haven't made your account yet, all you need to do is say sign up at Google. I'll redirect you to your Google account, and you just select the account you want to register your Paperspace account with. It then takes you to the landing page of Paperspace, where you have to choose between either Gradient, which is what we will be using, which allows you to basically deploy machine learning models on a cloud computing surface. So once you select Paperspace, right, so Paperspace and then onto Gradient, which takes you to this page. Well, we'll be running a Jupyter notebook, so please select run a sample notebook. All right, so Gradient, run a sample notebook. Okay, so Matthias has sent you a team invitation, and you can select your team on the bottom left here. It should show all the teams that it should show private workspace right now, since that's what you're assigned to originally. But you should be able to see an invitation to architecture and AI. I would like to go ahead and accept the invitation and then set the team as architecture and AI, since this lets you get access to, say, the paid machines as well as more other functionalities which are locked behind a subscription. All right, so if you have managed to get to this, or you are still doing this, just to track, I guess. So I guess to repeat again, Paperspace, you sign up with whichever platform you feel comfortable. Takes you to first landing page where you select Gradient. And once you've done that, and once you have, then you go on to selecting the team, where you should have received an invitation, and you select architecture and AI. All right. I am assuming that everyone has reached this point, and if not, please mention in the chat. From this point on, what we need to do is basically upload the data to, okay, so I'll basically give you an overview of what we are supposed to do. So, all right, so today we'll try to implement a 2D to 2D style transfer experiment, whose objective is to basically extract the style from the style image and apply it to the content image. In this case, our style image is the famous Great Waves of Kanagawa, and we're applying it to a cityscape. And then we hope to achieve the stylized result as depicted here. So to run this experiment, we need a couple of input arguments as such. The first would be your input images, which would be your content and the style images. To run the experiment and to manipulate the output, you will have access to something called the content weight, the style weight, and the iterations, which is the number of iterations your model will run. So think of these parameters as knobs. So if you think of the style transfer model as a black box, these are the knobs which are tunable, and you can tune these to get a desired output. You can also qualify or quantify how well your output is by keeping track of metrics, such as the content loss, the style output, style loss, and the output itself. And basically, the main idea is to basically play around with these knobs while looking at these metrics to get a desired result. So first off, we need to upload these images onto the storage that Alexa mentioned. So to do that, what you need to do is first go to Notebooks, which is here on the tab under Gradient, and you will then go on to create a new notebook. For choosing a container is basically different types of APIs that you can run this model on. For our experiment, we'll choose Paperspace plus FastAI. Then we go on to choosing machine. For all our experiments, we would prefer to either use P4000 or P5000. For in this case, say I select P4000, and you would like to ensure that the storage region is set to East Coast NY2. Some machines, it might vary depending on where you're logging in from, but for most of you, it should show East Coast. After that, I guess that is all you need to specify to set up your notebook. You can skip these. We can set length, which basically sets how long this notebook will last, and it will expire after the time it's done. But you can stop the notebook.
I actually would like students to get into the habit to put this set of hours a bit lower. Instead of 12, just put 6 hours.
All right. So you can vary the set hours right here. And well, since our workshop only lasts for an hour, for now, I'd like everyone to set it to 1 hour. But as Matthias mentioned, you would prefer to set it to a lower hour amount because most of the work you won't need the notebook running. All you usually need the notebook for is to upload the data. So you can skip the workspace and the workspace password and just go on to create a notebook. When you click on the create notebook button, it basically, it'll start up provisioning for a notebook on the machines that you mentioned. In case it stays pending for too long, you can cancel it and you can shift it to a P5000. I hope everyone's following. Otherwise, I can repeat. So you go to Notebooks, then you go to Create Notebook up here on the top middle right. Here you select the container. For now, we're using Paperspace plus FastAI. We choose a machine where it would be preferable to choose P4000 or P5000. Then you set the time limit, hopefully somewhere between 1 to 6 hours, and then you just create the notebook. And that should take you back to this.
Just quickly, it can happen that all machines are occupied. This happens occasionally. If this happens to you, you can select the next bigger machine and try again.
All right. Meanwhile, for the data that we need to upload, I'm going to share a Google Drive link on the chat. Okay, so once you have a machine up and running, what you would do is you click on open, you try to open the notebook, which should take you to a view that looks like this. All right, so on this Google Doc is the link to the repository and also the data that we need to upload. So there are two ways of uploading data onto the storage space. One would be just to, so for the first one, I'd like you all to just open this link, and this will basically download a zip file onto your system. Okay, and what we do next is we go back to the notebook, and there's a upload button right here. So we choose to upload this zip file that we just downloaded. Actually, no, you want to first go into storage and then try to upload the zip file. So it shows what file you're uploading, and then you just click on upload, and this basically uploads the zip file that you just downloaded onto your system, onto the cloud machine that you're running.
Manus, just a quick question. Is this the usual MAT file that we always have? Because it's quite big. It could take a while to upload.
Yeah, so for the MAT file, since it is huge and not everyone might have this bandwidth, I have an alternative method of downloading it directly to the cloud system. So that is the second way, but I'll get to that once this file has been uploaded, I guess. All right. How do you get ready to upload again? So what you do is you open the notebook, and then that should load up a screen that looks like this. And then you go to the upload button right here, and this should load up a window where you can select the file that you want to upload. And so you select the A4 style file that you just downloaded onto your system, and then you click upload, and this should, keep in mind, try to do this inside the storage folder that you, so, okay, I'll open up my window. Sure, okay, so since I uploaded it once, and we share a common storage space, so the others don't need to upload it, but this is, I was just showing how to upload data onto the storage space, all right? So you can choose to upload it if you want. It will just replace the file right here. Okay, so going on next, what you need to do is...
One second. One thing which is important, when you upload files, yeah, if you select the file, you just click upload, it's not going to be cut it. There is actually a second time that you have to click on upload to really upload the file.
Yeah.
So don't we...
So if, like it shows here, you need to click on this upload again for it to actually upload the file onto the storage. So that you have a zip file in the storage space, what you need to do is unzip it. So to do that, what I'd like everyone to do is go to new and click on terminal. So this loads a terminal screen, which is basically a command line interface. It is, I will give you a few command line cheat sheet which lets you interact with this terminal. So I'll go through these commands one by one. Right. So the first one is pwd, which basically stands for print working directory. So what it does is if you do execute this, if you do pwd enter, it shows where your what directory you're in currently. All right. To change a directory, what you'll do is okay, so I'll go to change directory first. So to change directory, so you do change directory, and well, you replace these braces with the path that you want to go to. So say I am in notebooks right now. Okay, yeah, I do need to show what ls does. So what ls does is it shows all possible files and folders that exist within notebooks. So pwd shows where you are currently, and ls basically shows what folders and files does this directory contain. So now you want to go into the storage folder. So to do that, what you do is you do cd, which is change directory, into storage. Now, if you do pwd again, now it shows that you're within storage. And when you do ls here, it will show all the files which are contained within the storage folder. So this files and folders. So you can see the A4 styles zip that you uploaded into the storage folder, which is displayed here. To unzip this, we have the command line has a pretty simple command called unzip, and followed by the file name. So here, okay, so the issue with this folder is there already exists a folder called styles. And if you look into the directory structure of the zip file inside, it extracts the zip file into a folder called style. So if I do unzip, all right, if I say go into styles and I print what it shows currently, that the styles folder has 3 images called Huron, Ledbo, and line vertical. Right? Now, if I unzip A4 styles zip file, so it basically unzips the file. And now if I go back into the styles folder and print it, it shows that the files that I just extracted are now present in the styles folder. So I extracted files by the name of Tübingen, the Stream, Starry Night, Muse, and Composition B. You can also, so now that I have unzipped it, you can also check what these files contain. What you do is you go here into styles and say you click on this, and it shows you what file it is that you unzipped or uploaded directly here. All right, for the second file, what we need to do is we need to upload these weight files. Now, one way of doing this is the same method that you did, where you open this link. This will download the .mat file onto your system, and then you can go back to the console and upload it. Choose to upload that mat file, and it will upload it. But the constraint on this is basically it is constrained by your internet speed. So another way of doing this would be to use the command line interface. To download it directly through the command line interface, you need to install a tool called wget. So what you would need to do is execute these 3 commands step by step. So first, you'll do apt get update, which, right? Then you go on to install, right? So what the first 2 commands do is basically they install a tool called wget onto your cloud system. And then finally, all you need to do is basically copy this line and paste it on your terminal. And when you press enter, it will directly just download the file onto your local system. So, which is, well, it's showing a ETA of 1 minute 30 seconds, which is, well, faster or slower depending on how constrained you are by your own internet speed.
Manas,
okay.
Just a quick question. Alternatively, you can download the folder to the mat folder to your desktop and then just upload it with the upload function, right?
Yes. So if you click here, it starts downloading the mat file onto your local system. And well, my internet speed is pretty slow. But once this is completely downloaded, or you again repeat the steps where you go to upload, and then you select the file from the folder, and it starts uploading back to the storage space that you have allocated. Okay, so it shows that it has downloaded. Well, the file already existed, so when I execute this command again, it tries to, it basically downloads an extra copy and renames it with .1. But, well, I've observed that this method tends, I mean, you can choose to do it either way. All right, so at this point, I think I'm gonna take a pause and hope that everyone has been following. If you have any doubts, you can ask me. And I'm just gonna remove the extra file since a version of it already exists on the cloud system. Right. I think when since it's a common since everyone's operating on the same what do you call it? Same team. Everyone is allocated to a similar storage space. So the storage space is shared. And hence, when everyone tries to access it, everyone has access to this file because someone previously uploaded it, and since everyone's accessing to the same memory space, everyone can access the file, which exists right here. All right. So again, there are two ways of uploading data. One is you download the file that you want onto your local system, your laptop or your desktop, and then you go here to your notebook, you select upload, and you select the file that you want to upload. So in this case, it was a4styles.zip. And then again, you click upload, and this should upload the file that you want onto the Paperspace storage. The other way, where you're trying to download large files and you're constrained by your internet speed, is a tool called wget, and what you do is basically you do wget and the URL to the file. So in this case, I can also do wget and this link to a4styles.zip, and it should do the same thing. It will download the a4styles.zip onto the storage space. I hope everyone has been following till now. Okay, now that you have uploaded the files that you want, so a4styles.zip basically contained images, which we will be using as the style image and the content image. So for our experiment, we will basically say use Tübingen as the content image, and we say try to impress the style of, say, the screen onto it. You can also choose to upload your own images. You can follow the same uploading trick where you just upload and say choose an image of your own liking, and you can choose that to be used as the content or the style image. Okay, so once this is done, well, that's the end of need for the notebook, because we don't really run the experiment through this notebook. So, well, for now, let's just keep, so in case you are done with this notebook, all you need to do is go back to the notebook section and choose the notebook that you're running and just press stop, and it will stop the notebook. For now, let's just keep it running because I'll try to show you how to store the data from the job experiments that you run onto the storage, and you should be able to view that. So now that you have uploaded the images and the weights, it's time to run the 2D neural style transfer experiment. So for that, what you need to do is go to the job section right here, and we will be setting up a job to run on this model. So you go to jobs, you select try the job builder right here, okay, and it leads you to this page. Okay, so for choosing a machine, again, you choose between the P4000 or the P5000, or if those are unavailable, then you go up, say, to the P6000, but usually P4000 and P5000 have more than enough compute to run these. Okay, so next up is the container in the workspace. So if you refer back to the GitHub repository, the link to which is present in the Google Doc. So you go here, and then you scroll down, and you'll see a link to something called the model zoo. You click this, okay? And this basically shows all the experiments which you can run directly by referring to the instructions. For now, we're trying to do the fourth experiment, which is the 2D neural style transfer. So if you go down here, we already uploaded the weights. Our images are already present. So now if you refer back to the console, it says that it requires us to fill in a container. The container is specified right here. So all you need to do is basically copy this and paste it here in the container section. The workspace again is again defined in the model zoo under the 2D style transfer example. We just again copy this and paste it right here in the workspace, third workspace section. You can skip defining the workspace reference. Okay. Next up is the command. So this command is basically what executes the model, right? So the basic, right. Okay. So to execute the command, to execute 2D style transfer, we have a command which is defined like this in the repository. The first two are basically defining which type of model style transfer to run. If you look back at the repository, there's a neural style transfer with no mask, and there's a neural style transfer with mask. For now, we'll be running the no mask example. So, okay, going back to the presentation, yeah. So Bash is basically define it. It's a program which will run this .sh file, which is defined. After that are the execution arguments. So, like I said, to run this example, we need a content file, a style file. The output directory is basically the directory where you will be saving your output of the model. So if you refer to the example here, our output directory right here is artifact. I will be showing a simpler command to run for the examples that we just uploaded. But for now, there are two types of output directories. One is artifacts, which basically stores the temporary output, the outputs associated with the model temporarily. And then you can also specify the output directory to be storage itself, where it saves the output to storage, and you can access that output at any point, even if you're done with the job. The next parameter is, the next argument is image size. So image size is basically the expected image size of the output. I think for the machines that we're using, P4000, P5000, the maximum that we can run it up to is 1024. So, but you can try varying the image size by a factor of, say, 128. So you can try 128, you can try 256, 512. It basically defines what the output height and width is of the final output image.
Sorry, can I interrupt for a second? This summer, I've been running experiments to go higher with the resolution, and you can comfortably go to 1526 by 1526 and get results out of it. And they will look better. The high resolution images just look a little better. For your first experiments, I would rather go with a small resolution just to make sure that it works. But once that it works, you can rerun the experiment and just increasing the pixel amount so that you get higher resolution images. I've successfully run experiments up to 2056 by 2056 pixels.
Okay.
I know that there's a Manas way to understand. There's a huge difference between when computer science people are working with resolution and architects are working with resolution. We really have to go higher with the resolution because those images need to be printed, for example, or they need to be published. And the really small images are not gonna, is a bit difficult. So as I say, start small and go higher then when you like the result. The result, by the way, will always look a little bit different. So if you have a 256 by 256 image, it's not going to look identical when you render the same image 1526 by 1526. Thank you, Manas.
Yeah. Okay, so the next parameters are the content weight and the style weight. So this is basically an importance value. So if you have the content and the style image, and you're trying to transfer the style from the style of the style image onto the content image, these parameters basically define how much importance does the output image give to each of these input images. So say if you set the content weight to be 100 and the style weight to be 1, right? So it's basically a ratio between the content image and the style image. So when you say 100 to 1, it's basically saying that the output should pay the content image 100 times more attention than. And you can try playing with these parameters. You can try setting content weight to 1 and setting the style weight to 100 and see how that affects your output. And these two values are basically related because it's basically a ratio between the two inputs that you're given. The last parameter is num iterations. It's basically the number of iterations your model is being run for. If in general practice, you'll observe that the higher number of parameters results in, it takes more time to run, but results in a better output in comparison to one with lower number of iterations, which runs faster, but has worse results. So going back to our experiment, so here, say, let's just try to copy the base definition of this command onto this, and we try making changes, okay? So for the content image, like if you go back to the storage space, you want to use, for now, we want to use, say, the tubingen.jpg. So you define the path, which goes as storage slash, well, the folder that it is stored in is styles, and then you mention the file name. For the style image, say we want to use Starry Night, so we simply do storage styles. For now, let's try using the output directory as artifacts. We try to generate an image of size 512 by 512. You can assign the content weight, say 100, and you set the style weight as 1, and you set the number of iterations to be, say, 100, right? And this is the command that is gonna execute on the cloud machine. So you can skip defining ports or custom metrics, and finally, all you need to do is basically submit a job. When you submit a job, it takes you back to the job directory, and it shows that I submitted a job, and it is, well, pending right now. So because I assigned a P4000, and okay, no. So it basically, it's similar to a notebook. It tries to assign a machine to execute this job, and as a machine becomes available, it gets provisioned, and we wait for this job to go through. Okay, okay, so everyone else is trying, but I'll go through the steps again to start up a job. So you go to jobs section, then you go to try the job builder. Here, you need to select a machine where you select between, hopefully between P4000 and 5000. The container and the workspace for each experiment is defined here in the model zoo. So for our experiment, it's a Carlson 32 new Styletransfer first image, and the workspace is the repository that we're using. So for another example, you can see that there are different container images defined and different workspaces defined that you can use to run this. After that comes the command, where you basically can look up the sample command, which is mentioned under each experiment. And for our current experiment, if this is the sample command, we try to set the content file, the style file, the output directory where we expect the model to store its output, the expected image size of the final output, the content and style weights, which are basically the ratio of importance between the content image and the style image, and finally the number of iterations for which we expect this model to run before it finally gives out an output. Okay, still vision. I think everyone else can try following the same steps. If your job gets stuck on pending, if you have any doubts, please feel free to ask me. If your jobs do get stuck on pending, try changing the machine from 4,000 to 5,000, since the number of machines allocated for running jobs might have run out, and you might need to shift to a higher machine. Okay, so the command line again. I can copy this and I can share this right here in the Google Doc. So this is the command that I am running right now for my job, where this is the .sh file that I want to run. This is the style source content image. This is the style image. This is the output directory, and image size, the content weight, the style weight, and the number of iterations. Okay. So once the job is completed, it will show the status as success. If it fails to execute the job, yes, you need to have spaces, because the way the command is being passed is basically each space defines a different argument. So you need to have spaces between each of these different arguments. So now that the job is completed, you can basically on this job. It takes you to a job page where it shows the log of how which was printed when this experiment was running. And since it was a success, we can go and check what the output was. So if you click on artifacts, since we defined the output directory as artifacts, you can directly access artifacts under this jobs. So again, if you want to access artifacts, you click on the job itself, and then there's a tab called artifacts, which has the output. And to view what this output looks like, all you need to do is basically, you can just select this and download it. It downloads it to your local computer. So say this is the output of my execution of that program. So since I've set the content weight to be super high and style weight to be, the content to style ratio is skewed towards content, it basically retains most of the structure of the content image, and it only incorporates some of the style of the style image. If I say I want to rerun this job, but I want to change the command line arguments. So under success, there is a rerun option. You just select this. It shows you again what type of machine that you want to run, the command that you want to run. So I'm going to keep everything same, but now I'm just going to set the content weight to 1 and the style weight to 100. And again, the container it's the same from the first job, so you don't need to change that. And you basically just rerun the job. Now, it starts up a new job, which is a clone of and it again is waiting for the machine. Instead of rerunning the job, what I could have done is started a new job where I fill in the same kind of machine, fill in the container, the workspace, and basically just change the command right here. So instead of running, I basically submit a job like this. And once I submit the job, it'll start up a new job under a new name, and you don't always have to basically wait for a job to finish before you can start a new job. In case you're having issues when your job is failing, I can. So it's you go back to jobs and you can see what the status of the job that you submitted is right here. So in my case, the rerun that I submitted has been just provisioned, and now I'm waiting for this. In case my job was completed, like in this case, it will show that it has success right here. And all you need to do is basically click on that job right here, and it will take you to this job specific page, which will show you the logs associated with the job and the output of the job. Right? Oh my God. My bad. My bad. All right. Okay. So if when you go to the jobs page, it shows you the status of each of the jobs that has been submitted. So you can see the status right here. In some cases, it failed, which I'll try to help out with. In some cases, it'll show running. Or in case of my first job, it was a success, so it shows success. And if you want to see the details of the job, you just click on it. It takes you to a specific page where it shows you the logs, and you can access the output right here in Artifact.
Maybe one more small detail. If you look into the jobs, there is between, let me just quickly check where this is exactly. Yes, if you look into the jobs, there is one line that says machine type, and there you see your machine, and then it says how much time actually passed until since you started your experiment. And if you're successful, between these two, there's a little colored icon. Yeah, and when you click on that icon, you can also go to artifacts and other information about your experiment.
Right. So when my rerun of the previous job has completed, and you can see that it has completed. It was completed since it shows success right here. So again, I go into the job specific page, and now I go to artifacts, and I try downloading this image onto. So when I shift the ratio, so now I set the content weight to 1, but I set the style weight to 100. And you can see that this has more, the output takes more, is more influenced by the Starry Night style image rather than the Tübingen content image. And so you can try messing around with the content and the style weights. You will notice that there is a difference in the output when you're setting, say, this content and style weight as, say, 25:1 versus setting them as fractions. And you can try to run experiments and see if you can figure out how and why it is showing that difference. So I am not sure if we are training a model. For now, we're just running experiments on the current setup. So yeah.
Great. I think we're pretty much at the end of the time. It's 4 p.m. We need to wrap up actually here. I mean, this was the entire process now to do the style transfer. Please be very careful not to have any typos in your code or additional spaces or anything like that, because that's like the things that normally makes the experiment go sideways. So make sure that your code is right. The description in the GitHub repository or step by step is really useful and good. There's a more general introduction into Paperspace also in the GitHub repository in the tutorials. If you have to repeat what Manas introduced you today for really going step by step through the written tutorial is super helpful. As I said, this is being recorded, so I will cut this down and put it also on our YouTube channel. So I guess by Monday, Tuesday, the latest, this should be online if you need to repeat this again. Your homework, as defined before, is to create one deepfake manually using Photoshop and whatever you think it could be, using one classic or iconic modern house, like, you know, the Farnsworth house or Boiling Water, or as Alexa showed today in her examples, Villa Savoye. and then do a sort of a style transfer deepfake manually with Photoshop, and the same thing using the process that Manas just showed you, the 2D to the neural style transfer. So this would be part of the homework. I will give you in the upcoming days also a reading task. And there's one more last thing I would like to do next time, rather shortly. I would really like to see from each one of you, the students, one project that you have done in the last 2 years, which you think represents your work the best, so that I can learn a little bit more about you and your abilities and your ideas and your directions. Okay, so for next time, the deepfake task and a really short 2-3 minutes pitch presentation of yourself, yeah, so that I can have a little bit of a better understanding, and we will take it from there. In the upcoming time, you will also get more information and more details about next meeting next week, yeah. And as I said, I set up this architecture and AI launch, which is going to be on SMUC. I will be during my office hours there if you need anything. And also, as said, setting up the Slack group. So if you have any questions, just hit me on Slack and we can talk about things. So again, careful with typos and spaces when you're doing code, and then it should be fine.